All right, this is section 11.2, arithmetic sequences and series. So this is simply a special type of sequence. It is a sequence in which every term after the first differs from the previous term by a fixed constant. That constant is referred to as the common difference, D. How do we find that common difference? Well, if we're given a sequence, we can simply subtract two of these terms. So 8 minus 5 is 3, but 11 minus 8 is also 3, and 14 minus 11 is 3. So a way to check whether or not this is arithmetic is to check each of those terms, one next to the other, and make sure that they each give us a common difference. So simply take, if you know it is arithmetic, you can just simply take two terms, subtract one term away, well, take a term and subtract its previous term. And that will give us the common difference of, in this case, 3. Okay, so the common difference will just be any term minus the previous term. If we rearrange this formula and solve it for a sub n, we get what? We get a sub n is equal to a sub n minus 1 plus d. Okay, so is this formula recursive or explicit? All right, so this form uses, in order to find a term, we're using the previous term, the n minus 1 term. So this is what we call recursive because it's using the previous term to find the next term, not explicit. Okay, so the next one, find D for this arithmetic sequence. So we're told it's arithmetic, so we can simply do 13 minus 20, clearly negative 7 is the common difference D. Okay. Next one, find the first 5 terms of the sequence described by the first term and the common difference. So the first term is negative 2.5. That was given to us. And then, so let's just put below it, that's a sub 1. And then a sub 2, we will simply add this to the previous term, so that's negative 2. That's a sub 2. A sub 3, we'll add 1/2 to that, so negative 1.5. That's a sub 3. Again, add 1/2 to that, so that's negative 1. That's a sub 4. And then the last term, negative 0.5. That's a sub 5. Okay, so if we would like to, we talked about a recursive formula up here. Let's talk about how we might come up with another type of formula. So I've written down a sub 1 is a sub 1. A sub 2 is simply a sub 1 plus d. And then a sub 3 is, you could start with a sub 1 and add 2 d's to get it. And then to get a sub 4, we could start with a sub 1 and add d 3 times. And then to get the fifth term, a sub 1 plus 4 d's to get a sub 5. So writing a formula in general, a sub n, we could write what? A sub 1 plus, now notice in order to find the fifth term, we used 4d. In order to find the fourth term, we used 3d. So in order to find the nth term, we want n minus 1 times d. So notice, in order to find the nth term, I'm not using the term right before it. I'm using the first term. So this is not recursive. This is explicit. Okay? All right, over the years, I've figured out that this formula is useful, but there's another one that is sometimes useful as well. And that formula doesn't use necessarily the first term, but some earlier term. So if I want to find a sub n, I could use a sub m. I'm calling m, a sub m just being some previous term, not necessarily the one right before or the one at the very beginning, but some other term. And then the difference in these two numbers tells us how many d's we are using to get to that term. So this formula is a useful one. Doesn't really have a specific name. I guess we would still call it explicit because we're not using the previous term, but we're using some earlier term. All right, so to determine, the next one, determine a sub n and a sub 16. Well, a sub n, we don't know how far out this is going, so we cannot actually find a number like 4. We're going to have to use a formula. So a sub n in terms of a formula. So let's use the original one. We know the first term is 23. And then we're going to use our n minus 1 times our common difference. Now, we don't know the common difference, so we have to come over here and figure that out. So 20 minus 23, or 17 minus 20, or 14 minus 17, all give me the same value. That's the common difference of -3. And so with a little algebraic manipulation here, we end up with a sub n equals -3n plus 26. So that is what a sub n is equal to. Like I said, it's not equal to an actual value because we don't know what n is. I don't know how many terms I want to go out to. If I knew what n was, I could find a sub n, but in this case, it's just a formula. All right, so now a sub 16, using that formula, so that's a -3 times 16 plus 26. That gives me a value of -22. So a sub 16 is -22. Okay, so in the next example, example 4, they're asking us to find the 21st term. They did not give us the first term. They did not give us the 20th term. They gave us the 4th term and the 7th term. They also, notice, did not give us the common difference. So how can we find the common difference? We can really use this alternative formula up here, comes in handy here to find the common difference. So if we put in the a sub 7 term, that's 30, is equal to, and then not the previous, but some earlier term, a sub 4, that's 18. And then we're going to add to that the difference of the two, so 7 minus 4 times d, which is unknown. So we just need to solve this for d. We move the 18 over, we divide by 3, and we end up with a common difference d of 4. All right, so that's kind of what we need in order to work the rest of the problem. So there's two different methods. You could certainly go back and find, use this term, a sub 7, and use it to find a sub 1. And we would use 7 minus 1 times the d, which we know is 4. All right, so plugging those values in that we know, so this one's 30 is equal to a sub 1 plus, that's 6 times 4, that's 24. And so we could subtract 24. And so a sub 1 could be found to be 6. So we could go back and find the very first term and then go ahead and use this formula here, the explicit formula. Certainly can do that. So now we know, let's find a sub 21 using the very first term, a sub 1, and this will be plus 21 minus 1 times the d. So now let's plug in everything we know. So we have a sub 21 we're looking for, a sub 1 we found is 6, plus, and then this is 20 times 4, and so that ends up being 86. So in order to use this explicit formula that the book gives us, we would have to first go back and find the very first term. However, I find it better to use the formula that I gave you up above, this other version or modified formula, where again a sub n is just some earlier term. So a sub 21 is equal to, let's say a sub 7 plus, and then we'll do 21 minus 7 times d. So we'll use this formula, and because we're using, it keeps us from having to actually go back and do this extra part over here where we had to find the very first term. So let's plug in everything that we know. So we know we're looking for a sub 21. A sub 7 is 30. You could have just as easily used a sub 4 in here, but then you would have to use this value of 4 here. So this is plus, and now 21 minus 7, that's 14. 14, and then that's what? That's D. D is 4. And so that gives us a grand total of 30 plus 14 times 4, or 86. Okay, so you can see we can do both formulas, do both methods. This one's clearly a little faster if you use this alternative formula. Don't think you'll find this formula in our book. Maybe our book has it, but a lot of books do not carry this formula. Okay, so now let's move on to series. And so it's an arithmetic series. So the only difference here is that the terms aren't going to be separated by commas. Rather, they're going to have plus signs between them. So, so it's called an arithmetic series if you just add up the terms of an arithmetic sequence. All right, so you decide to borrow $3,000 to take a course at a local community college for the summer. You will repay the loan by paying $100 towards the principal plus 1% of what you still owe each month. After the first month, you pay $100, and then you pay $30 because you still owe, then that's the interest, and so you have paid $130. At the end of the second month, you will have paid off $100, so you still owe $2,900, and you will pay $100 plus the interest that you still owe, which is $29, so $129. If we want to know how much interest you are paying at the end of the loan, we could look at the sum of the sequence. So it'll be 30, 29, 28, and so on, all the way down to 1, or that's the sequence, or we could look at the series, and so find the sum of the interest payments. So in other words, we're looking at something like a summation, 30 months, I equals 1 to 30, and this is going to be 31 minus I, so that'll generate 30 the first time, and then I will be increased by 1 each time, and so the first one will be 30, then the next one will be 29, and so on. All right, so one way to do this really quickly, go down to 2 plus 1, and then we'll be done. So if it's arithmetic sequence, and you probably saw I did this in some of the examples on the last worksheet, is if it's arithmetic, then I can look at the first and last terms. That's 31. What about these two terms? That's also 31. And indeed, each pair is going to be the sum of 31. And then how many pairs are there? Well, there's 30 terms total, and so 30 divided by 2 tells me how many pairs I have, times 31 for each pair. So that's a very quick way of adding that up. So it should be $465, much faster than even taking a calculator and adding all those numbers up. That takes a little bit of time. All right, so the general formula for the sum, S sub n, remember that's the sum of the sequence. Now, assuming it's arithmetic, we're going to have the number of terms divided by 2, and then we're going to add the first term and the last term. So you can see that's what we did up here. We add the first term and the last term. That ends up being 31. And then how many terms? And then we divide by 2. All right, so we have another formula. If we sort of plug the formula for the a sub n for this formula in here, then we could sort of generate this one as n over 2, a sub 1 plus, and now the formula here, an a sub 1 plus n minus 1 times d. And so simplifying that a little bit, as an alternative, we have n over 2, and then 2a sub 1 plus n plus 1 times d. All right, so those are two formulas that you could use to add up the sum. This one really should have a subscript of an n on it. the sum of the first n terms.